Let's look at antiderivatives. If we drop a ball, its height after t seconds is h of t. Its velocity after t seconds is h prime of t, v of t. Its acceleration after t seconds is h double prime of t, which is v prime of t, or a of t, negative 9.8 meters per second, at least on Earth. On the Moon, gravity is only 1/6 as strong, so a of t is negative 9.86 divided by 6, in other words, negative 1.6 meters per second. In other words, the acceleration due to gravity on Moon is weaker because the Moon is smaller, it's less massive. Find a formula for the velocity after t seconds. In other words, if a of t, which is v prime of t, equals negative 1.6 meters per second, find v of t. Again, we're talking about velocity on the Moon. This is not the kind of problem we've seen before. In the past, I've given you v and asked you to find v prime. Now we're doing the reverse. I'm giving you v prime and asking you to find v. V is what we call the antiderivative of v prime. V prime is the derivative of v. V is the antiderivative of v prime. So in general, an antiderivative of f is a function whose derivative is f of x. Here are some examples. The derivative of x squared is 2x, so an antiderivative of 2x is x squared. The derivative of x cubed is 3x squared, so an antiderivative of 3x squared is x cubed. It's like the reverse of the derivative. X cubed is not the only antiderivative of 3x squared. Can you name another one? Well, there's x cubed plus 1, because when you take the derivative of x cubed plus 1, you get 3x squared. Or how about x cubed plus 10? Again, when you take the derivative of x cubed plus 10, you get 3x squared. In general, the antiderivative of 3x squared is x cubed plus c, where c is a constant. That is the general form of the antiderivative of 3x squared. The symbol we use for antiderivatives looks like this. So this is the symbol for the antiderivative of 3x squared. Sometimes we call this the integral of 3x squared dx. The dx just means that the variable is x. We'll see later why we use this symbol and what the dx really means, but for now, it's just part of the notation. So for example, again, the integral of 3x squared dx, the antiderivative of 3x squared, will be x cubed plus c. In the same way, the antiderivative, the integral of 5x to the fourth dx, that's just going to be x to the fifth plus c. Okay, so notice, if the antiderivative of 5x to the fourth is x to the fifth, then the antiderivative of x to the fourth, just plain x to the fourth, that's going to be x to the fifth over 5. Because when you take the derivative of x to the fifth over 5, the 5 comes out front, so you got 5x to the fourth over 5, the 5's cancel, and you're just left with x to the fourth. And in the same way, the antiderivative of x to the 10th is going to be x to the 11th over 11 plus c. The general rule is that the antiderivative of x to the n is x to the n plus 1 over n plus 1 plus c, as long as n does not equal negative 1. Because if n is negative 1, then the denominator is 0, and that makes no sense. So for example, find the antiderivative, find the integral of x to the 100th dx. Now that's going to be x to the 101 over 101. Because again, the antiderivative of x to the n is going to be x to the n plus 1 over n plus 1 plus c. In this case, n is 100, so this exponent here is going to be 101, and the denominator is going to be 101. This rule works even when n is not a positive integer. So for example, find the integral of square root x dx. Well, square root x dx, that's just x to the 1/2 dx. In other words, it's x to the 3/2 over 3/2 plus c, and dividing by 3/2 is the same thing as multiplying by 2/3. So we get 2/3 x to the 3/2 plus c. Or, how about find the integral of 1 over x squared dx? The integral, the antiderivative of 1 over x squared dx, well, let's rewrite that as x to the negative 2 dx. So here, in this case, n is negative 2, so n plus 1 is going to be negative 1. The antiderivative of x to the negative 2 is x to the negative 1 over negative 1. Because again, it's going to be x to the negative 2 plus 1 over negative 2 plus 1. And this exponent is negative 1, and the denominator is negative 1. So be careful, it's not x to the negative 3 over negative 3. Let's see, that's the same thing as negative x to the negative 1 plus c, which is negative 1 over x plus c. Here's some other helpful rules for derivatives. The integral of kf of x is just k times the integral. This is where k is a constant. So the integral of 5x squared dx, that's just going to be 5 of times the integral, the antiderivative of x squared, which is x cubed over 3 plus c. How about the integral of 8x? Well, that's just going to be 8 times the integral of x. In other words, 8 times x squared over 2 plus c, which is 4x squared plus c. The integral of f plus or minus g, that's just the integral of f plus or minus the integral of g. So the antiderivative of the sum is just the sum of the antiderivatives, and ditto with the difference. So for example, the antiderivative of 5x squared plus 8x is the antiderivative of 5x squared, 5x cubed over 3, plus the antiderivative of 8x, which is 8x squared over 2. And you don't need to write plus c twice, just have one plus c. The antiderivative of k dx is just kx plus c for k a constant. So for example, the antiderivative of x to the 5th plus 12, that's going to be x to the 6th over 6 plus 12x plus c. Okay, now suppose f prime is 8x and f of 1 is 10. Find f of x. Well, the antiderivative of 8x is 8x squared over 2 plus c, 4x squared plus c. So f of x is 4x squared plus c. But since we know that f of 1 is 10, we can find f of x precisely. So we can figure out what that c is. We don't just have to say 4x squared plus c. We can nail it down. Now f of 1, based on this formula, is going to be 4 times 1 squared plus c. In other words, 4 plus c. Why did I plug in f of 1? Why did I plug in x equals 1? Because we know that f of 1 is 10. So f of 1 is 10. We were told that. And we also know from this formula that f of 1 is 4 plus c. So when we would compare these, we can see that 4 plus c is 10, and therefore c is 6, at least in this particular problem. So f of x is not just 4x squared plus c, f of x is 4x squared plus 6. And again, the reason we can nail that down, the reason we don't put just plus c, is that we were told this initial value of f. Okay, let's go back to the original problem we saw. Let's say the acceleration, which is v prime, is negative 1.6 meters per second squared. Find v of t. V prime is a, so v is the integral, the antiderivative of a. Integral of a of t dt, that's the integral of negative 1.6 dt, which is just negative 1.6 t plus c. But we can find c. We don't have to settle for just this. Do we know the velocity at any time t? Do we know it at t equals 1? No. T equals 10? No. But we dropped the ball. So we know the velocity at time t equals 0 is 0. We have this initial velocity. So what we do is plug in t equals 0. Okay, so v of t is negative 1.6 t plus c. Plug in t equals 0, and we end up with negative 1.6 times 0 plus c, which just works out to be c. But the reason we plugged in t equals 0 is that we know what v of 0 is. We also know that v of 0 equals 0. So v of 0 equals c, and v of 0 equals 0. That just means that c equals 0. So v of t isn't just negative 1.6 t plus c. V of t is negative 1.6 t plus 0, or just plain negative 1.6 t.